The Big Bang is the start of our universe, but there's a silence before that first note. The question of what came before it, that pushes everything to the limit. Science, philosophy, all of it. I want to lay out 15 different scientific models for you. 15 ways to answer that. They reshape how you see reality. Completely, we'll look at whether our universe is just one chapter in an infinite cycle of cosmic rebirth, and if everything we know could be a hologram. A projection from the very edge of nothing. What do you think is there beyond the beginning of time? That silence before the Big Bang. It might not be silence. It could be an echo, the last fading note of a universe that existed before ours. That's the idea of a cyclical cosmos, a universe that breathes, inhaling into a hot, dense collapse, then exhaling into a vast, cool expansion. So the Big Bang, in this view, isn't a beginning from nothing. It's a rebirth, a cosmic phoenix rising from the ashes of its own past existence. The concept feels ancient. It echoes those old philosophies about endless cycles of creation and dissolution, but now it wears the sharp suit of modern mathematics. One of the strongest versions is called Conformal Cyclic Cosmology, pioneered by the physicist Sir Roger Penrose. He proposes that our universe's far future and a new universe's explosive beginning are mathematically the same state. You picture it, billions upon billions of years from now, our universe expands into a cold, dark, nearly empty void. All that might be left are faint particles of light, the evaporated remnants of black holes. In that vast stillness, the concept of scale loses all meaning. Distances become irrelevant, and through a profound mathematical transformation, that cold, empty end can be reshaped, conformed into the hot, dense seed of a new Big Bang. One cosmic epoch, what Penrose calls an eon, gives way to the next. There's no singularity at the start, just a smooth transition from one cycle to another. Our entire history, from the first flash of light to the last dying star, it becomes just one chapter in an infinite book. It elegantly sidesteps the need for a definitive beginning. It offers a vision of time without end, but it raises a haunting question. If the universe cycles forever, what set the wheel in motion in the first place? Or was there ever a first turn at all? That infinite cycle still needs a starting point for the first turn. So you go deeper. You ask if the universe didn't come from a prior universe, but from a state that is, for all intents and purposes, nothing. And that's where the rules get strange. The quantum fluctuation model asks you to reconsider emptiness. In our everyday world, nothing means an absence. An empty box is just a box with nothing in it. But in the quantum realm, empty space isn't empty. It's a restless sea, a churning sea of potential. Particles and their opposites, matter and antimatter, they flicker into existence and then out. They borrow energy from the void for an instant, then vanish, paying the debt back. This is allowed by a fundamental rule, the Heisenberg uncertainty principle. On the smallest scales, certain properties aren't fixed, energy and time. There's always a tiny uncertainty, which means the conservation of energy, that sacred law in our large-scale world, can be temporarily bypassed. At the quantum level, so this quantum nothingness isn't a serene void, it's unstable, a seething foam of possibility. Physicists like Lawrence Krauss frame it this way: in the quantum world, nothing is unstable. Given enough time, and in the absence of any pre-existing time, the fluctuations in this primordial field could have become permanent. A tiny bubble of spacetime could have tunneled from a state of zero size into an expanding universe. That process is called quantum tunneling. It's like a particle appearing on the other side of a mountain without ever climbing over it. Our entire cosmos, in this view, is that ultimate fluctuation. A single, statistically inevitable event in an eternal sea of nothing. It challenges cause and effect. There was no prior event, no first cause in a traditional sense. The universe could be its own cause, a spontaneous emergence from the restless potential of nothing. So when you look up at the night sky, you're not looking at the aftermath of an explosion from a single point. You're witnessing the stabilized aftermath of the most improbable, yet most fundamental event, a random bubble that grew into everything. But if a universe can pop into existence from nothing, why just one? Could our cosmic home be just a single bubble in a vast, frothing ocean of realities? That bubble might be part of a much larger froth. If a universe can come from a quantum fluctuation, it probably wouldn't happen just once. So the multiverse idea takes that to its logical end. Our Big Bang wasn't a unique event. It was a local thing, one bubble forming in an endless, inflating sea of spacetime. Like a pot starting to boil, steam bubbles form, they expand, they detach and rise on their own. Our whole cosmos is one of those bubbles. The medium, the boiling water, is what's called the inflationary multiverse. It's a meta-reality where space itself is hyper-expanding, stretching faster than light can move through it. But this inflation isn't the same everywhere. In some spots it slows down, it stops, and when it stops, that local region releases all its stored energy. A flash of heat and particles, that's a Big Bang. That's the birth of a pocket universe like ours, and this process doesn't end. New bubbles keep forming in that inflating background, each with its own Big Bang, forever separate from the others. That's eternal inflation. It means what we call the universe is just our local pocket, one island in an archipelago so vast it might have no end. Physicists like Max Tegmark sort this into levels. The first level is almost simple. If space is infinite and matter is spread out roughly like we see, then every possible arrangement of particles has to repeat. Somewhere far beyond our horizon, there's another Earth, another you, reading another version of this. The second level brings in those bubble universes, each with possibly different physical constants. Maybe in one, gravity is stronger and stars die fast. In another, the nuclear forces are too weak to make atoms. Our universe, with its precise constants that allow for galaxies and life, stops being a miraculous coincidence. It becomes a statistical inevitability. If you have an infinite number of universes with random laws, a few will, just by chance, have the right conditions. We just happen to be in one that works. It sidesteps the question of why our laws are so fine-tuned. They didn't have to be. We just won the cosmic lottery. The implications are huge. Every possible history, every potential reality, might be playing out somewhere in this ensemble. It changes the fundamental question. We stop asking what came before our Big Bang. We start asking about the architecture of the greater reality that gives birth to these events. What are the rules of the inflating metaspace? And if it generates universes, what generated it? That line of thought leads to a more radical possibility. That the ultimate reality isn't a place of space and time. It's a realm of pure, static information. The cosmic code idea leads to something disorienting. That the solid world you see and touch isn't the fundamental reality. It's a projection, a hologram, and this isn't science fiction. It's a principle from black hole physics. The holographic principle says all the information to describe a volume of space can be encoded on its two-dimensional boundary. It's like a movie. The three-dimensional world on screen doesn't exist inside the projector. It's all on the flat surface of the film. Our universe might be that movie. Its whole history, every galaxy, every person, could be information painted on a distant cosmic film. At the edge of everything, physicists like Leonard Susskind suggest the Big Bang might just be the moment this cosmic projector was switched on. Before that, there was just the film. A static surface holding the entire script of reality, in a form we can't read. This connects to a mathematical discovery. the anti-de Sitter/conformal field theory correspondence. It's a duality. It shows a universe with gravity is perfectly equivalent to a quantum system without gravity living on its outer shell. One is a translation of the other. So gravity, the curvature of spacetime, the dimensions we move through, they aren't primary. They emerge. They are the consequence of quantum information interacting on that lower dimensional surface. Your feeling of being here, in a body, in a room, is the result of a complex calculation happening somewhere else. This reframes the question of what came before. There was no before in the way we think of time. There was just the code, the data. The information that defines our cosmos existed without time or space. The Big Bang becomes the moment that information began to process, to render, creating the illusion of a past, present, and future unfolding. It makes our tangible reality a shadow. A rich, convincing shadow, but a shadow nonetheless, of a simpler truth written in 2 dimensions. If that's the case, what kind of data could manifest a cosmos? And who or what is running the projection? A projection needs a screen, a bounce needs a floor, so there's another way to avoid a singularity, not with a hologram but with a rebound. Like a cosmic rubber ball, you squeeze it, it compresses, it gets dense and hot in your hand, but it never shrinks to a point. There's a limit, and then, when the pressure is greatest, it pushes back. It bounces. That's the bouncing cosmology. It replaces the Big Bang singularity with a big bounce. Our expanding universe wasn't born from nothing, it was reborn. From the collapse of a previous cosmic era, time stretches back before our Big Bang into a phase of contraction. A prior universe, maybe like our own, grew old. It ran out of steam and began to fall in on itself, galaxies drawing closer, the background heat of space rising, everything compressing toward a single, ultra-dense state. In classical physics, that compression just continues into a singularity, a point of infinite density where the laws break down. But modern physics, a theory called loop quantum gravity, says quantum effects step in at the smallest scales. Space isn't smooth, it's woven from tiny, indivisible threads, a fabric with a finite weave, so there's a smallest possible volume, a quantum graininess to the cosmos. As the old universe contracted toward that scale, it couldn't shrink further. Instead, the quantum nature of gravity created a repulsive force, like a spring compressed to its limit. That force became the engine of the bounce, reversing the collapse into the explosive expansion we call the Big Bang, so the moment of highest density wasn't an end. It was a turning point, a cosmic reset, a universe that breathes in and out over eons, cycling through expansion and contraction, maybe forever. It solves the singularity problem. There's no moment where physics fails. There's always a before, but it introduces a possibility, a universe with memory. The information that defined the old cosmos, the arrangement of its quantum fields, might not have been erased at the bounce. It could have been imprinted, scrambled maybe, onto the newborn universe. The patterns we see in the cosmic microwave background, the large-scale structure of galaxies, might carry faint echoes of a world that came before. A thread of continuity woven through the cycles, so our universe isn't just another random iteration. It could be the heir to a legacy, carrying forward, in some transformed way, the story of everything that collapsed to give it birth. That legacy suggests a past, but what if there was no past, not in the way we think? The Emergent universe model, it asks you to consider a cosmos without a birthday. A reality that just was forever, in a state of perfect frozen equilibrium. Imagine a sculpture carved from a single, flawless diamond. It sits in a museum, unchanging for an eternity. No story to it, no before or after, it simply exists. That's the pre-Big Bang state here, a timeless, static configuration, a cosmic egg that never needed to be laid. Physicists like George Ellis revisited an old idea from Einstein, the Einstein static universe. It's a solution to his equations, a cosmos neither expanding nor contracting. A delicate balance, the inward pull of gravity perfectly countered by an outward push, originally from Einstein's cosmological constant. In its original form, that balance is unstable. The slightest nudge sends it collapsing or expanding, but with modern tweaks, exotic forms of matter, adjustments from quantum gravity, this static state could be metastable. It could persist unchanged for an indefinite duration, no ticking clock, no arrow of time, just a permanent, silent now. Then something happens, a quantum fluctuation. A tiny ripple in one of the underlying fields. It's like a single grain of sand falling onto one side of a perfectly balanced scale. That tiny perturbation is enough. It breaks the symmetry, the delicate balance shatters, and the outward pressure wins. The static universe awakens. It begins to inflate rapidly, exponentially, transitioning into the hot, dense state we call the Big Bang. So in this view, the Big Bang isn't a beginning of everything. It's a phase transition, a change of state for a universe that already was, like water, sitting calmly in a supercooled state, suddenly crystallizing into ice at the slightest disturbance. This model removes the need for a creation event. The universe has an infinite past, though that past is featureless, unchanging. It challenges our intuition. We're wired to think in terms of cause and effect, stories with a first chapter. Here, there is no first chapter. The book was always there, its pages blank, until one sentence suddenly began to write itself. The most profound implication is about time. In that static state, time may not have flowed as a sequence of events. It was just a coordinate without direction or meaning. The emergence of the expanding universe didn't just create space and matter. It may have created the arrow of time. The flow from past to future could be a product of the expansion, not a prerequisite for it. So when you ask what came before the Big Bang, this model answers a forever of stillness, a state where before has no definition. Our vibrant, evolving cosmos, with its galaxies and life, becomes a fleeting pattern in an eternal existence that was, for almost all of its history, utterly quiet. But if a universe can transition from timelessness to time, what other fundamental properties might be emergent? Could even the laws of physics themselves be temporary features of our current cosmic chapter? But the laws of physics, if they're emergent, maybe they aren't laws, they could be code, and that opens up a model that's both audacious and unsettling. Our universe from the Big Bang to right now might be a simulation, a programmed genesis, and this isn't just science fiction. Philosophers like Nick Bostrom treat it as a statistical argument. If a civilization gets advanced enough, it would create vast, detailed simulations with conscious beings. Over cosmic time, the number of simulated minds could far outnumber the original ones. So statistically, we're more likely to be simulated. In that framework, the Big Bang isn't a physical explosion. It's the initialization sequence, the moment the runtime began. The singularity is the boot-up screen, and the laws of physics aren't fundamental truths. They're the programmed rules, the algorithms that govern how the virtual world renders. The constants of nature, those finely tuned numbers for atoms and stars, they're not miraculous. They're just parameters chosen by the programmers, maybe to see what kind of universe would unfold. Or maybe they're just default settings. This model leans on information theory. It suggests reality at its core is mathematical. The universe behaves like a vast computation. Space and time and matter are outputs from an unimaginably complex processing substrate. So what existed before our Big Bang? In this view, the before is the hardware and the software of a higher dimensional reality. The computer running the simulation, our entire cosmic history, is a narrative being processed, a story told by mathematics, and this idea can explain puzzles. The strange quantum behavior where particles exist in multiple states until observed, that could be an optimization. The simulation only renders details when someone is looking to save processing power. Unexplained cosmic anomalies might be glitches, or they could be deliberate Easter eggs left by the creators. The simulation hypothesis forces a confrontation. It asks what we mean by real. If every sensation, every memory, every law is generated by a process outside our perception, does that make our experience less meaningful? It also stretches the definition of a scientific model. It's untestable in any conventional way, but it emerges naturally from trends we see in computing. From our own creation of virtual worlds, it represents the ultimate extension of the idea that information is primary, that mathematics might not just describe the universe, but actually be the universe. A running program in a realm beyond our own. This speculation, while dizzying, points toward a final category of models, ones that suggest the most fundamental layer of existence isn't a substance or a force. It's a pure, abstract structure, a timeless mathematical truth waiting to be instantiated. The most distant future of our cosmos is a profound emptiness. Every star has burned out, every black hole has evaporated, just a slow whisper of radiation. All that's left are faint particles of light, photons, drifting across a vast, cold expanse. And in that state, the concepts of distance and scale start to dissolve. Everything is so spread out it might as well be infinitely close. But in one view, this isn't an end. It's a prelude. Sir Roger Penrose proposed something called conformal cyclic cosmology. It says that distant, empty future can be mathematically transformed. Rescaled, it can become the ultra-dense, hot beginning of a brand new universe. The mechanism is a kind of geometry, conformal geometry. It deals with shapes where angles are preserved, but distances are not. Like a map projection of the Earth, the relative directions between cities are correct, but the sizes of continents are stretched. In this cosmic geometry, the infinite, cold emptiness of one cosmic epoch, what Penrose calls an eon, can be conformally mapped onto the hot, dense singularity of the next. So the before of our Big Bang isn't a separate creation event. It's the conformally equivalent future of a prior eon. The model bridges the infinite scale difference. The end of one cycle, where everything is infinitely far apart, is geometrically identical to the beginning of the next, where everything is infinitely close together. It's a reset of the cosmic clock, but not the underlying mathematical reality. And this isn't just elegant theory. It makes a testable prediction. If our universe was born from the remains of a prior one, then the titanic collisions of supermassive black holes in that previous eon would have sent immense gravitational shockwaves across spacetime. When our universe formed, those waves would have imprinted as subtle, concentric rings of temperature variation in the cosmic microwave background, the afterglow of our own Big Bang. Penrose and colleagues claim to have found statistical evidence for just such patterns. It's controversial, debated, but the possibility is there. It suggests we might look into the fossilized light of our own birth and see echoes of a cosmos that died long before ours began. Information might pass between the cycles, not stories or structures, but fundamental imprints on the geometry of reality itself. So it's a picture of eternal recurrence. Not identical events repeating, but potential being reborn over and over. Each eon unfolds with its own unique history, its own stars and galaxies born from the ashes of the last. And it leads to a question. If traces of the past are written in the sky, what other signatures of a forgotten cosmos might be hidden, waiting to be decoded in the data all around us? String theory says the fundamental things aren't particles, they're these tiny vibrating loops, strings. and for the math to work, they need more dimensions than the 3 of space and 1 of time we see. They need extra dimensions, 6 or 7 more maybe, all curled up incredibly small, so small we can't see them. But that shape, the shape of those curled up dimensions, it determines everything. It sets the laws of physics in our big, visible universe. How the strings vibrate decides what particles exist, what forces there are. The geometry sets the strength of gravity, the mass of an electron. The nature of light, this leads to the string theory landscape, a cosmic catalog of possible universes. Each entry is a different, stable way to fold those extra dimensions. Each fold gives you a different set of physical laws, a different recipe. Our universe, with its specific constants that allow atoms and galaxies, is just one possible fold. One entry in a near-infinite library. So what was before our Big Bang? In this view, the before was a higher dimensional realm, a primordial soup of possibilities where no single geometry was fixed. A quantum superposition of every possible fold. Then something like crystallization happened. Through a mechanism called vacuum decay or quantum tunneling, the system settled. It picked one stable configuration from the landscape. That specific folding of dimensions became our local reality. The energy released by that settling, that selection, that was the spark. It triggered the violent, rapid expansion we call cosmic inflation, which then became the hot Big Bang. Our entire cosmos is the aftermath of that one cosmic dice roll. Theorists like Leonard Susskind place this within eternal inflation. The higher dimensional landscape is eternally inflating, but in pockets, it randomly tunnels into one of the stable folds. Each tunnel creates a bubble universe with its own Big Bang and its own laws. We just live in one such bubble, defined by the particular geometric luck of our draw. This ties the smallest and largest scales together. It suggests the answer to what came before is tied to the deepest puzzles of particle physics. The origin of our universe might not be a singular explosion, but the silent, mathematical selection of a shape from an endless array. A selection that wrote the laws of nature into the fabric of everything. The Ekpyrotic universe, it's a model where the Big Bang wasn't an explosion from a point. It was a collision, a shattering impact. You have to picture our reality not as a bubble but as a sheet, a three-dimensional membrane, a brain, drifting in a higher dimensional space. Like a single page from a book floating, and there's another page, a parallel brain floating nearby. All the particles and forces we know, they're stuck on our brain. They can't leave the page, but gravity can. Gravity leaks out into the higher dimensional bulk. It becomes the tether between these floating worlds, so the story starts long before our time. The two brains are parallel, separated by a tiny gap in this extra dimension, and they're not static, they're drawn together, moving slowly over an immense period. As they approach, the space between them contracts smoothly. There's no singularity, no point of infinite density, just a steady, gentle closing of a cosmic gap. And this slow contraction, it stretches our brain. It flattens it, irons out any wrinkles. All the potential energy for creation is stored in the motion itself. In the kinetic energy of these approaching worlds, then they meet. It's not a head-on crash, it's a glancing, resonant collision, a silent, titanic shudder rippling through the fabric of both brains. And in that moment of contact, the kinetic energy of motion is converted, violently, transformed into a seething, hot plasma of particles and radiation that floods our three-dimensional sheet. That's our Big Bang, not a beginning from nothing but a rebirth from impact. The heat, the density, the explosive expansion, all of it is the aftermath. After the impact, the brains rebound, they move apart, and our universe expands and cools in the way we observe. Stars form, galaxies coalesce, but the story might not end there. The forces at play could eventually reverse the motion. drawing the brains together once more, billions of years from now, for another collision, another cosmic reset. It suggests a cyclic history, an endless, stately dance of approach, impact, and separation across the hidden dimensions. This model solves puzzles. The smooth, flat geometry of our universe comes naturally from the stretching during the slow approach. The tiny seeds for galaxies, the density perturbations we see in the cosmic microwave background, they arise from quantum ripples on the brains themselves. Stretched to cosmic scale by the contraction, and then ignited by the collision, it gives us a new origin story, one where everything we are, every atom, originated in the reverberations of a clash between worlds in a realm we cannot perceive. The most profound events in cosmic history might be happening in directions we cannot point, in layers of reality folded just beyond our senses, a universe without a beginning. It really pushes against how we think, but it might be the most elegant answer. Stephen Hawking and James Hartle had this model. It doesn't start with a bang. It starts with a gentle curve, the no-boundary proposal, and it asks us to think about time differently. In our normal world, time is a line, an arrow. Past to future, but at the extremes with quantum gravity, Hawking said we should use a different kind of time. Imaginary time, which isn't make-believe. It's a mathematical tool. You treat time like a dimension of space for the calculation, and when you do that, something happens. The jagged point of the Big Bang smooths out. It rounds off. Think of the Earth. It has a north pole, but that's not an edge. It's just a point on a smooth surface. You can go north until you reach it, but you don't fall off. You just start going south. The no-boundary universe is like that. Its beginning is like the cosmic North Pole, a point on a closed, four-dimensional surface. Where time as an imaginary dimension becomes space-like, there's no boundary, no wall, no sharp edge where it all begins. It's a geometry without a start. So the question, what was before the Big Bang, it loses its meaning. It's like asking what's north of the North Pole. The framework doesn't allow for a before. There's no classical time before that moment. Instead, the universe is most probable to emerge from a state of zero size, in this smooth, rounded way. Hawking and Hartle used the path integral approach, summing up every possible history a quantum system can take to calculate the probability of our universe appearing. And the answer favored a history without a singular, violent beginning. The origin is visualized as a tiny, fuzzy, four-dimensional ball, where the crisp line between time and space dissolves into a quantum haze, and this isn't just a mathematical trick. It's a shift in thinking, from a temporal beginning to a topological one. The universe doesn't have a birthday in time. It has a shape in spacetime, a self-contained geometry that just is. So the arrow of time, the flow we feel, emerges gradually as the universe expands and cools from that smooth, timeless state. Our whole history of cause and effect, of past leading to future, becomes a property that crystallizes inside the cosmos, not a precondition for it. It offers a kind of closure. An answer that dissolves the question by showing the question was built on a flawed assumption. That time is fundamental. Maybe it's not. Maybe time itself is emergent. Born from the geometry of a universe that, in its most basic description, has no beginning and no end, just a serene, self-contained existence, gravity might not have been the first thing to build the cosmos. There's another force, one we use every day, that could have shaped it from the beginning: electricity. The plasma universe model from the Nobel laureate Hans Alfvén, it flips the usual story. It sees a cosmos that's always been full of a kind of seething, electrified gas, plasma. In this view, there's no emptiness before the Big Bang. Instead, there's an infinite, dynamic ocean of charged particles. Always there, evolving by the laws of electromagnetism, the same ones we know from our labs. So the Big Bang isn't the absolute start of everything. it gets reinterpreted. A local event, maybe even a mythicized one, inside a much vaster and older meta-galaxy. Just a single flash in an eternal storm. This idea draws its power from known physics. In space, over 99% of the visible matter is plasma. Stars, nebulae, the solar wind, Alfvén and others, they propose that on the largest scales, this plasma is threaded by electric currents that span galaxies. Immense magnetic fields, these forces, not just gravity, could have sculpted the large-scale structure of the cosmos. Those vast filaments of galaxies we see might trace the paths of cosmic circuits. Galaxy clusters forming where the electrical junctions get dense. It's a universe built not just by the slow pull of mass, but by the dynamic push and twist of electromagnetic forces. And that means a radically different timeline, an eternal, quasi-steady state universe, matter continuously created and rearranged, no definitive starting gun. No singularity, just an endless process of transformation, governed by the same principles that light a neon sign or guide a bolt of lightning. It challenges the need for a creation event at all. It suggests our entire cosmic history is just a chapter in an infinite book, a book with no first page. The evidence for this is debated. Proponents point to filamentary structures in the universe, intricate magnetic fields that seem hard to explain by gravity alone. Critics argue the model can't cleanly account for the thermal signature of the cosmic microwave background. That definitive afterglow that so perfectly matches a hot, dense beginning. Still, the plasma universe stands as a reminder. It asks if we've been too gravitational in our thinking, overlooking the electric currents that might flow through the veins of reality. It proposes a cosmos without a birthday, forever alive with the crackle of charged particles. The silent flow of power across the void. Our place in the cosmos might be what tints how we see its beginnings. There's this idea, anthropic reasoning. It's a quiet shift. The thought is, any universe we can actually think about has to be a universe that can produce thinkers. We're a selection effect. A kind of filter. It doesn't give you a new equation for what was before the Big Bang. It gives you a rule for sorting through possible models, a way to judge which ones could ever matter to us. It asks why the laws seem so perfectly set for life, gravity's strength, the forces inside atoms, the amount of dark energy. Tweak any of these just a little and stars don't form. Chemistry gets impossible, the universe stays sterile. In a single, unique universe that looks like a miracle, maybe evidence of a designer, but in a vast multiverse where countless universes bubble up with random laws, the mystery just goes away. We would obviously find ourselves in one of the rare ones that allows life. We couldn't be anywhere else. The before in that picture is a chaotic, generative process. It makes every possible outcome. Our specific cosmic history from its pre-bang conditions to now is just the one slice that allowed observers to appear. So when we ask what was before our Big Bang, the anthropic answer is subtle. It says the viable starting conditions are the ones that lead, through lawful, unguided processes, to us. That changes the question. It moves from a pure search for a first cause to something more statistical, almost logical. We aren't the goal of the cosmos. We're a consequence that then looks back and wonders why things were just so. It makes the search for origins deeply personal, yet strangely impersonal. Our existence acts like a spotlight. It only lights up the histories that could have led to this moment, to us asking, all the other possible universes, the vast silent majority with no life, no light, they stay in the dark. Unobserved, never asked, this perspective humbles our models. It reminds us our physics, our cosmology, isn't a detached map of some objective reality. It's a story the universe tells about itself, through minds that the universe somehow grew. Looking for what came before becomes partly a search for the logical prerequisites of our own consciousness. That filter of our own existence opens up a final possibility. The ultimate reality might not be physical. It could be mathematical. That's the mathematical universe idea. From the physicist Max Tegmark, it says our physical reality is just one specific mathematical structure, and it exists because that structure is logically consistent. There's no deeper why to find. In this view, the Big Bang isn't a physical event in time. It's a feature, a logical consequence inside the equations that define our particular mathematical object. So the question of what came before the Big Bang changes. The before could just be other mathematical structures, an infinite, timeless library of every possible self-consistent mathematical system. Some are simple, empty sets, basic geometries. Others are vastly complex. They encode every possible history, every conceivable set of physical laws. Our cosmos, with its 4 dimensions and 12 fundamental particles, is just one entry, one chapter in an eternal Platonic catalog. This model gets rid of the need for a physical cause. Mathematical existence doesn't need a creator or a prior state. A perfect circle, the number pi, the relations of a triangle, these don't get built, they just are. They exist in a non-physical, abstract sense. If our universe is mathematics, then it exists for the same reason 2 + 2 = 4. It's a necessary truth. This pushes anthropic reasoning to its limit. In that vast ensemble of all mathematical structures, only a tiny fraction will contain self-aware substructures. Beings like us who can perceive and model their own reality. So we find ourselves not in a randomly generated physical universe, but within the specific mathematical structure that allows for our complex consciousness. Our perception of flowing time, of 3-dimensional space, of cause and effect, that's just the way this particular mathematical object feels from the inside. It raises a profound question. Why does this particular set of equations feel like anything at all? Why is there a subjective experience attached to the processing of this cosmic data? The mathematical universe hypothesis doesn't answer that. It just reframes the mystery. It suggests that consciousness itself might be a type of mathematical pattern. A certain complex, self-referential arrangement of information that, when instantiated, lights up with awareness. So we are not just in a mathematical structure. We are that structure perceiving itself. This is the ultimate multiverse, not of bubbling spacetime, but of pure, disembodied truth. It challenges everything. Our intuitive notion that something must have physically happened to start it all. Our belief that reality is made of stuff. Here, the stuff is secondary. The relationships, the logic, the patterns, they are primary. The cosmos is a grand, silent symphony of mathematics, and we are a fleeting melody within it, momentarily aware of the score. As we get to a final reflection, this idea makes us ask what the goal of our search even is. Are we looking for a first cause in a chain of events? Or are we trying to understand the timeless, necessary framework that makes any event possible at all? The fabric of reality might not be a fabric. It could be a network, a vast, shimmering web, a web of cause and effect. That's the vision of causal set theory. It asks you to forget the smooth, flowing spacetime of Einstein's universe. That continuum is an illusion, an approximation. It emerges from something more fundamental. Something granular. At the very bottom, reality is built from discrete events, elementary happenings. You can think of them as the universe's most basic pixels. Not pixels of space, but of spacetime itself. Each event is a point, and these points are connected by one simple rule, causality. One event can influence another, or it cannot. This creates a partial order, a cosmic map of what can affect what. This collection of events and their causal links is a causal set. It's the proposed substrate of everything. In this picture, the universe before our Big Bang wasn't a dense ball of energy. It was likely a sparse, jumbled network, a causal set that didn't yet look like a smooth, 4-dimensional continuum. It was non-manifold-like, a tangled web of potential influences, no clear geometry, no distance, no smooth flow of time as we know it. Then a phase transition occurred. A cosmic crystallization. Through a process still being mapped, this sparse network reached a critical density of events and connections. And from that complexity, a recognizable order emerged. The web began to approximate a smooth, continuous manifold. The discrete points, seen from a vast distance, blurred together into the space-time we experience. The Big Bang, then, is not a singularity in a continuum. It's the moment of this transition, the tipping point where the fundamental, discrete architecture organized itself. Organized into the familiar, flowing stage where everything now plays out. What we perceive as the beginning of time is an artifact of this emergence. Our arrow of time, the relentless flow from past to future, arises from the direction of causality in the network. Before that transition, in that sparse pre-geometric state, the concept of before is different. It's just a question of which events in the network can influence others. There is no singularity to fear, because in a discrete set, there are only a finite number of elements preceding any given event. You can always trace the chain of causality back, link by link, but you will never reach an infinite density. You'll never reach a point where the mathematics breaks down. The universe simply has a first event or a first few events in its causal history, no infinity required. This model grounds the entire cosmos not in stuff but in structure. In the pure mathematics of order and relation, the universe is not a thing that exists in space and time. It is, at its heart, a pattern of causality. A story written in the language of cause and effect. Every particle, every star, every thought is a vast constellation of these fundamental events. We are not just in the web. We are the web perceiving itself, from endless cycles to quantum bubbles, from holograms to colliding brains, and now to a universe woven from pure causality. Each model is a different lens. A different answer to the silence before the first note. They don't all agree, they can't all be true, but together they map the frontiers of our wonder. They show us the question of our origins is not a search for a single moment in time. It's a journey into the nature of reality itself. And perhaps the most beautiful discovery is that in asking what came before everything, we are ultimately learning what it means to be here now. In a cosmos that allows such questions to be asked at all, there are 15 distinct paths through the silence. They all lead to a single crossroads. Each model has its own vision of Genesis, the cyclic one, the simulated one. But when you put them side by side, patterns start to show deep commonalities. Stark conflicts, you can see where our understanding is being forged, and a striking number of them converge on this one radical idea, that the universe might have no true beginning. Not in the classical sense, the cyclic cosmos, the big bounce, the plasma universe, they all describe an eternal process, a reality that just always was. Transforming from one state to another without a definitive starting gun. For these models, the Big Bang isn't a creation event, it's a transition, a phase change in an infinite story. Other models take a different approach, more subtle. They don't propose an eternal past. Instead, they redefine what a beginning even means, the quantum fluctuation model. It posits a spontaneous emergence from a restless void, the no-boundary proposal. It describes a smooth, rounded geometry without an edge. In these pictures, the question, what came before it, loses its footing. Because the framework for time itself emerges alongside the universe, there is no before, not in the way we intuitively understand it. This creates a fundamental divide. In the landscape of thought, on one side, models that require a pre-existing meta-reality, an inflating false vacuum for the multiverse, a higher dimensional bulk for colliding brains, a cosmic computer for the simulation. These frameworks embed our universe within a larger, more fundamental arena. Our Big Bang is a local event inside a grander, perhaps eternal, architecture. On the other side stand the models of self-contained Genesis, the universe from nothing, the no-boundary state, the mathematical universe that simply is. Here there is no larger arena. Our cosmos, with all its apparent history, is the ultimate level of reality, or it emerges from a logical necessity, a quantum necessity. That requires no prior stage. This is the core tension. Is our universe a chapter in a much bigger book, or is it the entire library? The drive to resolve this tension is fueling our greatest theoretical leaps. And you notice something. The most promising models, regardless of their answer, they share a crucial tool. They invoke theories of quantum gravity to dismantle the terrifying singularity. String theory offers extra-dimensional folds. Loop quantum gravity provides the repulsive force for a bounce. Causal set theory replaces the continuum with discrete events. Each one uses a quantum picture of spacetime to smooth out the infinite point, to replace the breakdown of physics with a new, more fundamental mechanism. This isn't just academic preference, it's a necessity. The singularity is a signpost. It reads, physics ends here. To go beyond, we have to rewrite the sign. And these different rewritings make different predictions. Some might leave faint fingerprints in the cosmic microwave background, concentric rings from a prior eon, or specific patterns from the collision of brains. Others might predict a background of primordial gravitational waves, a faint hum from the first instance of inflation. With a frequency that tells us about the energy scale of the event, the search for what came before is no longer purely philosophical. It's an experimental frontier. An observational frontier. We are mining the oldest light in the sky, listening for the faintest ripples in space-time, looking for clues to our own origin story. Ultimately, this synthesis reveals something about the human endeavor, the quest to understand the before. It's the engine forcing quantum mechanics and general relativity into a unified conversation. The rules of the very small and the very large. It's pushing science to grapple with questions of existence, causality, time, questions that were once the sole domain of philosophy. Each model is a different answer, but collectively they are a map of our current ignorance and of the breathtaking landscape we are trying to explore. The very fact that we can conceive of such a dazzling array of possibilities, it tells us we are asking the right question, and that the answer, when it finally comes, it won't just tell us how everything began. It will reveal the deepest architecture of reality itself. We've looked at 15 different models for how the universe began. From cycles that never end to quantum beginnings from nothing, each one is really a way of asking the same question. What came before? None of them is the final answer. But each one changes how we think. They challenge different things we assume, like whether time only moves forward, or if the world we see is even the whole story. Some ask if math is more real than matter. Together, they stretch what we can imagine. The point isn't to find one neat answer, it's the questions themselves. Each model is a tool, a lens. It shows us our intuitions might be incomplete, our ideas of cause and effect, of nothingness. They're limited by the very universe we're trying to describe. So this isn't an ending, it's more like standing at an edge, looking into that silence before anything, and letting that wonder stay open, to look up and see not just stars, but the question of where they came from, to feel the possibility in not knowing. If one of these ideas stuck with you, you can share it below. Tell me which model feels most compelling. The conversation is part of it, and if you want to keep exploring mysteries like black holes or alien worlds, you can subscribe. Thanks for joining this. A journey to the beginning of everything, or maybe to where our idea of a beginning is still being formed. Keep wondering.